Today's lesson is 10.3 on page 408, Scientific Notation, and we're going to focus on the larger numbers. So scientific notation always has to have a times 10 in it. It has an exponent to tell you how many places over you move your decimal. And before the decimal, there needs to be one number in front of it to be standard form. So you could have 1 times 10 to the second power, and that equals 100. And you could put 1.0 also, but it's the same if you put 1 times 10 to the second power or 1.0 times 10 to the second power. If you have 1.2 times 10 to the second power, it stands for 120. So how I got that is 1.2, if my power is 2, then I move this decimal over twice and I fill in any missing gaps with 0. So let's go to number 7. So let's see. We have 5,800,000. So in this, we know it's automatically times 10. We know standard form needs to have one number before the decimal. Well, the first number in my big number is 5 for the decimal, and then any numbers behind the decimal. I normally don't put zeros behind it if it's not in between two numbers of different values, so I just put 5.8. And then I need to find my exponent. So to find your exponent, you start right here at the end of the number because you have an imaginary decimal point right there, and you just count over until you get to the decimal we added in between the two first numbers. So 1, 2, 3, 4, 5, 6. So it turns into 5.8 times 10 to the 6th power. And we do the same thing right here. So we have 7,300. So we know we have to have one number before the decimal, so we put a 7 there. Then we put our decimal point. Only other number we have to write is that 3. We know it always has 10 to some power. And then we just count over how many spots. So we go 1, 2, 3. So 7.3 times 10 to the 3rd power. In the case that you have decimal already in it, so we have 387.65. We know we need to have one number before the decimal. We're going to write the remaining numbers after the decimal. So 8765. We know we always have it times 10 to some power. Then we start where the decimal is. We go over how many places we have moved our decimal. So 1, 2. So that turns into 3.8765 times 10 to the 2nd power. Just like that. On number 20, we have a 0 in here. We still need to have that 4 represented in our scientific notation. So we know we have to start with 6, put that decimal down right after the 6. Then we have 504 behind it, 504. We know it's times 10, and then we just find what power. So we start at the back of the 4, and we go over 1. Whoopsie. 1, 2, 3. So we went over 3 places right there. Okay. And if it just asks for you to find what n is, so n is your exponent, you just find how many places you moved it over. So 570 turned into 5.1 times 10 to the nth power. So we go from right here and we find how many places we moved it over. 1, 2. So we just put n equals 2. Oh, but I need my I need my book. Yep, you can play with those. My nephew's helping me today. Whoopsie. Better move my coffee. Okay, thank you. Thank you. Thank you. So, if we have, thank you so much. If we have 274.6 times 2.746 times 10 to the nth power, all we have to do is count over how many places we moved our decimal. So it's 1, 2. So again, n equals 2. Just like that. On number 6, n equals 1 because you only moved it once. Over here, n equals 3, 6, 7 because you moved it 7 places. So you just have to count how many place values you moved it over.